Welcome once again to a time value of money video. This time we're going to look at question number 10. And I want to start by noting what we did last time in question number 9 because number 10 relates to number 9. And what we did in the last equation, the last problem, was we effectively noted that the principal reduction payment that we made at date 18 was equal to the payment amount, which was $1150.15, multiplied by a present value interest factor for an annuity where the R was equal to 0.0725 divided by 12, and N was equal to the number of payments that we wanted to eliminate, which was the last 120. And this right here, we saw gave us the $97,967.61. And then we multiplied that by a present value interest factor where we had the same R, right? The same R, 0.0725 divided by 12. And the N there was the number of periods we're moving back in time, which was 222. So that's what we did last time. And therefore, when you multiply this by this, that's how we got our 25,723.95. Just to show you, that's what we did. And I want to make one point here, very important, and that this N right here in the PVIFA was the number of payments to be eliminated. Okay, and I also want to make note that this N here in the PVIF was equal to the original N minus the date of prepayment, PP, minus the number of eliminated payments. And so for us, it was 360 minus 18 minus 120. And so 360 minus 120 is obviously 240 minus 18, and this is our 222. Okay, so that's just very important to realize. And again, I'll just outline this in pink, the importance of this little equation right here. It's a very important equation. Now, so keep that equation in mind, okay? Now, let's look at problem 10. Problem 10 says, consider the loan described in number 9 above. Suppose that instead of determining the size of a principal reduction payment that you should make to eliminate a specified number of scheduled payments, that's what we did last problem. We're going to, figure out how much we had to prepay to eliminate the last 120 payments at a specific date. Last problem was date 18. Now we assume we desire to prepay $50,000 on date 18, and then it's kind of a different way of looking at the same thing. How many of the originally scheduled monthly payments will no longer be necessary? So in the last problem, we were given the number of payments that wouldn't be necessary. We said we didn't want to pay the last 10 years worth, 120. And then we figured out how much of a prepayment to make in the last problem at date 18. Now we say, hey, we're going to prepay $50,000 at date 18. How many of the originally scheduled monthly payments are no longer necessary? So this becomes what we're solving for. Okay, so please spend some time thinking about how this is very similar. So in this case, we can say that the principal reduction payment, PRP, that is going to be made at 18, this is the same formula for problem 10 and problem 9, is equal to the payment okay, times PVIFA, where for us R is equal to 0.00604. You know there's more. And N is the number of payments to be eliminated. I'll just call it elim. Okay? And then we multiply that by a PVIF, where we have the same R, 0.00604. And N is equal to 360 minus date 18 minus the number of payments to be eliminated. Okay, so that's the equation, except now in question number 10, what we know or what we're given is this. Okay, so it's like we're using the same equation to solve for a different value, and the value we're going to solve for is this elim right there, which also appears right here. Okay, so let's have at it. We're going to prepay $50,000 at date 18, and the payment we know is $1150.15. And so here is our PVIFA, and we know that we're just going to call this elim. We'll call it E in these formulas here. Okay, so it's going to be, this PVIF is going to be 1 minus 1 over 1.00604, and I'll say to the E power, okay, and divided by the 0.00604. So that is the PVIFA. That's this. Okay, now times this PVIF, which will be 1 over 1.00604 into the power 360 minus 18 minus E. There we go. There's the E again. And so now we want to solve this equation, which I will now circle, or not circle, but enclose in this awkward pink colored shape. We want to solve that for the only variable in the equation, which is E. Okay, so this is a nice algebra review. So let's look at this. Okay, so let's start off by multiplying both sides of the equation by 0.00604. That'll get rid of that. And at the same time, let's divide both sides of the equation by 1150.15. So that means over here I'm going to have 50,000 times 0.00604 divided by 1150.15. Okay? And then on the right-hand side, what we're going to have is the numerator here. I'm just going to write it a little different. I'm going to write it 1 minus 1.00604 to the minus E power, right? To the minus E power. Just a little mathematical notation. Ends up being convenient, right? It'll help us. And multiplied by this, I'm going to write that differently also. I'm going to bring the numerator, I'll bring the denominator up. So multiplied by 1.00604. Now I got to multiply this by minus 1. So I'll get minus 360 plus 18 and then plus E, right? Up here, it was 360 minus 18 minus E. Now I'm multiplying it by minus 1 because I'm bringing this term up top. Multiplying that by minus 1 gives us negative 360 plus 18 plus E. Okay, now we just have to solve this for E. Okay, so, well, I guess one thing we can do is, Oh, by the way, I forgot to put parentheses. I'll use square brackets around this. Very important to do this. I should not have forgot that, but I did. Now it's corrected. Okay. So it's this term multiplied by this term. So I guess I'll do that. 1 times this is equal to 1.00604. To the, well, I guess I'll lump the minus 360 and the plus 18. I'll say minus 342 plus E. Okay, and then minus, well, we have the same base here, 1.00604, and then when we multiply two terms that have the same base, each base having an exponent, we then add the exponent. So the minus sign is going to carry through here, so I have 1.00604. This is a 0 here. 1.00604, and then I add the exponent, so I have minus E plus E, so the E cancels out there. I'm left with minus 360 plus 18, or minus 342, and that's going to be equal to this value over here. I'll just put that little notation there. Okay, so again, so it's super clear for you, I'll just use a little pink thing for that. There we go. Now, let's go to purple. Next, well, the variable we're solving for now appears only once in the equation, right there, E. And as I've mentioned before, whenever the variable that we're solving for appears as an exponent, we like to make use of natural logs. So I'm going to take the natural log now of both sides of this equation, and we'll be left with the following. The natural log of this term here, 50,000 times 0.00604 divided by 1150, 15. Okay. I guess I might as well bring this term over, right? Might as well bring that term over. And, you know, it'd just be part of the left-hand side. I guess I could have done that first. And I end up taking the natural log of that anyhow. So plus 1.00604 to the minus 342 power. Okay, so again, all I did was I took this term over here and then took the natural log of everything. So that's, you know, just so don't get confused with that. That's no big deal. And then I'm left with taking the natural log of the other side, which of course now is going to be equal to minus 342 plus E. Put that in parentheses. Okay, times the natural log of 1.00604. Okay, there we go. So this is our equation, and let me see. We can solve this for E pretty easily. All we have to do is divide both sides by the natural log of 1.00604 and add 342 to both sides. If I do that over here, I'll just be left with E, which we're solving for, and then let's see what we get on the other side. Well, it's pretty obvious. Tell you what, let me change the color to blue. Let me erase this. Now I'll change the color to blue. Okay, and what we're going to be left with is the following. I said we have E over here, and we're left with the natural log of whoops, what did I do? The natural log of this term here, 50,000 times 0.00604 divided by 1150, 15, plus 1.00604 to the minus 342 power. Okay. Divided by this term, the natural log of 1.00604. And then, of course, I have to add this, go back to pink for just a second, I have to add this, it's minus 342, so I have to add 342 to both sides, right? So I just say plus 342, and that equals E, right? So here, I'll just make that a little more clear for you. All this equals E. And that's our answer. When you carefully crank out that, you will observe that E is equal to 185.72. 185.72. And that is the number of eliminated payments. Excuse me. Well, once again, we have to do some interpretation here. Well, this means that 185 payments will be eliminated. And there will be a 186th payment that won't be eliminated entirely, but it will be a much smaller payment than it would have been. So we don't eliminate 186 payments entirely. We do eliminate 185 payments entirely, and then some portion of one more payment. So again, the number of eliminated payments is 185.72, 185.72. And again, the detail was we eliminate fully 185 payments, and then the payment that precedes those that are eliminated, which will be the last one we make, will be a partial payment. And that's all for this video. Thanks for watching.